Hey everybody, it's noon, so I'm going to get started on this Lunch and Learn. Lunch and Learns are a short version of some I've been doing deeper dives in the past. You certainly can look those up. There is a deeper dive on this very tool, which is the motion tool inside SolidWorks, as well as the animator. But I wanted to give everybody a quick overview of it, so we're just going to take about an hour and look at some of the tools that SolidWorks allows us to do when it comes to motion. Here on my add-in, I've turned on the SolidWorks motion. This motion comes, I believe it's with Professional. It used to be in Premium, but they moved it down. That allows you to do the kinematics package that I'm going to be using here in SolidWorks. If you guys could mute your microphones unless you're asking questions, that'd be great. And I'm going to jump in here. So I've already got my motion turned on, and I'm going to be working in the assembly. I have a blank assembly here. SolidWorks allows you to do multi-bodies inside of parts, but they don't really move. If you want to have motion that's easy, like click and drag, not actually adding a feature to move them, then assemblies is the way to go. I'm going to insert a component, and anytime you put a component into SolidWorks, the very first component is going to be fixed in space. It's a good idea not just to click somewhere on the screen. You want to hit the origin. You'll see that when I move my cursor over the origin, it snaps into place. You can also do this simply by hitting the green check mark in the insert component. Hitting that green check mark or dropping something in on the origin, what it does for me is not only is the part fixed in space, but the 0x, 0y, 0z are all the same, and my front plane and top plane, all that. It's all in the same orientation as the original part that I dropped in. You'll see it has this little F in front of it. The first part, by default, is going to be fixed like that. Any other part, like if I take this one here, if I drop it in here, it's going to be free floating, but if I hit the green check mark like it did with my first part, any part that's dropped in like that gets dropped in wherever the origin was. In this case, I've modeled the part in the correct location. And that'll happen a lot, especially if you're using like a master model. And it's a good idea for assembly performance. If you look, there's no mates. It's just held in place. So SolidWorks doesn't have to solve where this is. It knows automatically where it is. So anytime you hit that green check mark to drop things in, it just drops it in on the assembly origin, matches to the part origin. Again, I talked about fixed and float, or I talked about a fixed component. If I right-click on a fixed component and choose float, then all of a sudden, I'm able to move it around. I'll quickly undo that because I do want it to be in that position. But you'll see that fix and float is just a toggle. So if you drop something in or you have something from the master model put in there, you can float it, and you're going to need to mate the thing into place to get the motion that you desire in your assembly. Let me explain. I'm going to put in one more component here. One nice thing that they added recently in SolidWorks is this orienter. So when I do move my component onto the screen, if it's not got the right axis, if it's turned a little, I can actually move it in 90-degree increments here using these. It just rotates it about the origin, or about that X, Y, or Z axis, the same axis that you see down here on your triad in the lower left-hand corner. Okay, so I've got a component. This one is free. You'll see that it has a minus symbol. Anytime you have freedom of motion, there's a little negative symbol in front of your component. It's not a bad thing. It just lets you know that that part is free to move. To move a component, if I left-click and drag, then I get to move this axially. And you'll see I can move it along the X, Y, or Z, up, down, left, right, back, forth. If I right-click on a component and hold my cursor down, and I move my mouse, then it'll rotate. Take a look up here. The magic that it's doing is it's turning on and off this tool for me. We're going to get more into that tool, but back in the 1900s, you used to have to actually click that tool before you could move it and then unsuppress it. So they've just made it a little easier, where it turns the move tool on for us and allows us to free drag. And you can move components right through each other, which makes it easy to assemble them. Here, I'll assemble this. I'll just hold my control key down, click a couple of faces. When I release my cursor and my control key, it tells me, I've got this little shortcut menu. I can put mates on pretty rapidly. I can select them out of the feature manager tree. Just make sure I've got them matched up right. There we go. And now I've locked down this motion. I used to have 6 degrees of freedom where I could move axially along every axis and I could rotate about every axis. As I put the mates down, the coincident mate locked down the rotation in 2 ways. The concentric mate with the coincident mate has locked it down, so all I can do at this point is rotate about the X. But that is actually what I'm after. If I wanted to fully define this, I certainly can. I'll just put a quick mate on here. Notice that I still have that minus symbol in front of the component in my feature manager tree. But when I put that third mate in, all of a sudden the minus symbol goes away. So if there's an F in front of your component in your feature manager tree in the assembly, it's fixed. If there's no symbol in front of it, then it's fixed by mating in place. It's not just a fix. A fix is just a, hey, lock this thing into the XYZ coordinates where it is. This one was actually manually locked into place. If you ever want to see what's holding a component together, if you click on it, this little mate with the eyeball is a nice one. You can take a look at which mates affect this. It'll also hide your assembly and only show the components that are affected by the mates that are on this component. So I don't need this one. I can actually make changes right from that screen. When I close out of the window, it brings back up my full assembly. So there we go. I've got a part that's got some freedom of motion. And I want to have that freedom of motion. But you'll see that in the free drag, SolidWorks really doesn't care if parts pass through each other. Again, it's nice for when I'm putting the assembly together, but at some point we want to start testing for things like collision. And that's where we get into what SolidWorks can do for you as far as a motion study and taking a look at how the components work together. So with the standard drag, if I click on it, nothing happens. You've also got a rotate. It's set off by free drag, but you can actually move it by delta X, Y, Z, or with rotate. You can rotate around a specific axis, something like that. So you can get a little bit more than just free drags from the standard drag. But I'm going to actually turn on this next one called collision detection. What collision detection does for me is instead of the components ignoring one another, when I go to move them, I'm going to do a move rather than a rotate.
Okay.
You'll see that it highlights
Okay.
the area for me. It also puts a ding on or something if you could hear that. And that lets me know that's as far as I can move that. And it's pretty nice because then I can start taking a look at things like what the angle of this is. So I'll pick the 2 planes, do a measurement, and see that it's just about 32 degrees. So that's one of the things that's cool about motion is the fact that I can actually test to see if there is any collision in between components, and I can get a range of motion and see if things work. You can take it a step further. If I hold my control key down, click and drag, hopefully you know that allows you to make copies of things in Windows. SolidWorks is the same, so make a copy of that component, go into my move tool again. Instead of using the collision detection that I just had on, I'm going to turn on physical dynamics. So what collision detection does for you is once 2 volumes run into each other, you're done. What physical dynamics does is it takes it the next step further, is once they run into each other, what's going to happen? You'll see that one component pushes the other out of the way. And not only is it pushing it out of the way, it's actually rotating, it revolves, it takes a look at its center of mass, at its moments of inertia, so it moves just like it would in the real world, sort of. We have to start putting in gravity and things like that to get more real world stuff. But again, now you get past, does this thing have the range of motion I'm after, to you can start testing linkages. When I pull this handle, does it make this bar turn this gear, or whatever you've got as far as a mechanical assembly, a system that you're doing. Okay, so that's just with the move tool. You can bump your move tool up to let you take a look at how things run into each other, or how things will interact with each other when they do run into each other. Let me put a couple more parts in here. I'll put some hardware in. So I'll drop one there. Told you about that control key, click and drag trick, get another one of them. But I also wanted to talk to you, since I take these things as a time to show you tricks, tips and tricks, things like that. There's a thing called Smart Mates. If you hold your Alt key down while you click and drag, if you're on a planar face and you click one planar face and drag it to another planar face, you can put on a coincident mate right away. You can do the same thing with a circular face. Hold the Alt key down, grab a circular face. When you hit another circular face, it wants to make them concentric. Notice that there's this choice for lock rotation. Right now, there's a minus symbol on my part because it's free to move. I've made it coincident. The concentric will also hold it, but it's going to be free to rotate about that concentric mate unless I turn on the lock rotation. And then you'll see the minus symbol is gone. If I take a look at my mates, there's a little dot. There we go. In the middle of that concentric. That just lets me know that concentric has been locked down, so I'm not free to spin around it. Okay, some more tips and tricks. Click and move this thing sort of into position. So I showed you coincident, concentric. We've got smart mates for them, and those are great. But a lot of times you want both of them, especially when you're putting in nuts, bolts, washers, screws, things like that. You want the screw to be in the hole and the head to be flat on the surface of wherever that hole is drilled into. So there's a smart mate that we can use specifically for that. If I hold my Alt key down, I grab a circular edge. Get that circular edge. There we go. And I move it to another circular edge. I get this little symbol that looks like a peg going into a hole. That's because this is called the Pagan hole smart mate. And you'll see that it has put in both mates for me at the same time. I can adjust them because I noticed that I got my coincident backwards. I can right click and flip the mate alignment on that one. It tells me it has to redo the concentric as well. That's fine. And then for this concentric, so when I put in the smart mate, it didn't ask me about the lock rotation. You can lock rotation after the fact at any time. Just right click on a concentric mate. One of the options is lock. So I can get these pieces in, not have to worry about them moving around. Okay, so that is my assembly. I do want to save it. And I'm going to get on to the next part, and that is making animations. There's lots of different animations we can make in SolidWorks. One of them is very basic. If I go into my configuration manager, I can make an exploded view. The reason you have to go into the configuration manager is you can have different configurations of assemblies. So one assembly might have 15 parts and one might have 35. Obviously, the exploded views are going to be different for those two assemblies. So exploded views are per configuration. So even if you only have one, this is the place to do it. I can say, let's do a new exploded view. And I want to pick this pin and the two pieces of hardware that I just put in here. I have an option down here for auto spacing components. If you have that turned on, when you drag your handle out to explode this view, it gives you a whole bunch of handles. It telescopes it, each part. How far it telescopes has to do with this setting that you've got here, a little or a lot. It's always going to get it wrong. That's why it leaves these little arrowheads for you, so you can fine tune it to get more of the view that you were after, like right there. Okay, I don't want to hit the green check mark because that's going to get me out of my explode. What I want to do is say, okay, I'm done with that explosion, and move to the next one. When I'm exploding views, you notice that when I select it, my triad, the XYZ, is the same XYZ here as the assembly. If you want to explode something along a particular direction, you just need to fill in this explode direction area. If you pick a flat face, it'll go perpendicular to that flat face. If you pick a straight edge, come here. There we go. It'll go along that straight edge at that angle. So it can be either reference geometry or a piece of geometry off a component. Again, sometimes it's not so good with the first drag, but it does give you the arrow head to adjust it before you get out of that explosion. Okay, I'm done with that one, and I'm actually done with the whole exploded view. So that was quick. If I double click on this, it collapses. If I double click it again, it'll explode. But I'd like to send somebody a small video of how to put this thing together so that I don't have to write out a bunch of work instructions or something like that. I can just send them this, and regardless of language, they're going to be able to see the geometry real time on their screen. How you do that is if you right click on an exploded view, there's a choice to animate it. And what it'll do is it'll go through, it gives you these little old VHS controllers, stop, pause, rewind, that sort of thing. I can go back and forth, just go through once or go in a loop. Whether I want to go fast or slow is up to me as well. But one more control right here is to save an animation. So this is the easiest way to make an animation in SolidWorks. I just click on this. It'll ask me to name it. I'll just put it on my desktop here, but before I do, I want to take a look at some of the controls. Automatically, it's going to take my entire screen size. I can play around with that aspect ratio if I don't want to use the screen size, but that's what it is by default. Also by default, they give you this ridiculously low frames per second. They're just trying to make a small AVI for you. But it's going to look choppy. Even if you go to 16, that's Charlie Chaplin speed, still going to be choppy. If you get more like 24 or 30, then it's going to be a nice smooth transition. So I'll hit save. It will ask me for compressors. Depending on which computer you have, you're going to have different choices on compressors. Since I have like Camtasia loaded here, I'm getting some other codecs and things like that. The largest one will be uncompressed. That's just basically snapshots. So it's going to be the largest file, but it's going to be one that anybody can read. So how this works is the longer I let it play, the longer the video is going to be. It's going to be recording until I finally hit stop. And then once I stop that animation, then it creates that video for me. So there we go, first animation. Let me get back into SolidWorks. Sure would like to, any screen. There we go. Okay, sorry about that. Back in my assembly. Okay, that was a pretty simple animation. I want to make one that's more complex at this point. So I'm going to do a few things. I'm going to insert one more component. This one's just for fun here. What do you do if you want to have text or something suddenly appear? We can do that. Also, I want to set up some views before I get into here, because my default isometric is that way. it kind of is upside down. I want to show the thing in this. So if you want to create your own view, here's how you do it. First, you get your component in the desired view that you're after. Something a little like that. When you hold your control key, that allows you to pan. When you hold your shift key, that allows you to zoom. So there we go. That's the view that I want to have for my isometric. So I'll hit my space bar. The space bar takes you to a point where you can change your orientation. You'll see it gives me the sides of the cube that I can pick from over here. Graphically, I can also pick if you have any saved views. My template that I'm using actually has some saved views already. But if you want to make your own, this is where you do it. This little icon, it's a telescope with the sun coming up over it. If I select on that, I can add this. So I'm going to call this Animation ISO. There we go. Now I've got a new view. I also want to look at this thing from the side. There's a couple of ways to orient parts. If you select a face and then you hold your control key and you select another face, when you go normal to, you look straight down at that face, and whatever the second face was is going to be at the top of your screen. So that's a quick way to orient things. Also, if you select on the triad down here in the left-hand corner, you can also get something like that where it's looking straight down the axis. If you see this is my right view, if I click it again, it's my left view. So you can use it to orient it or flip it 180 degrees as well. So that's sort of the orientation I want, except it's upside down. If I start to rotate it, the thing's going to get discombobulated as far as me looking normal to the right plane. So another trick with the Alt key, if you hold your Alt key down and you use the arrow keys on your keyboard, it does a flat spin visually. So it's just rotating it in orientation of your computer screen. Hold my control key down, maybe get this thing centered up a little bit. There we go. And I'll hit my space bar and give this one a name as well. Animation side. Okay. So now I want to make an animation. There's a couple of ways of doing it. If you go to the Insert tool, if you have your motion study, if you have the add-in that I showed you at the beginning turned on, you can do a new motion study here. You can also do it just by clicking on this little double dot here. There's two different places I can be. I can be in the model, which you're used to, or I can start a motion study. When you do that, it brings up this toolbar, or this pane, I should say. You can minimize it with this arrowhead over here in the corner. Or if you want to close out of it, you need to select over here and go back to the model. Okay. I want to get this thing set up. The reason that I closed that motion manager is I kind of messed up right there. If you have this thing showing the wrong parts or in the wrong orientation when you start your motion study, that's the orientation in the show that SolidWorks is always going to have at start 0. So when you start playing your animation for a split second, you're going to see wherever it was when you started. So it's a good idea to get it in the orientation that you want it. And if you have anything that you want hidden or shown, do that before you start your animation. I'm opening up this little display pane. If you've never used it before, these different columns allow you to do things like change the color of the part, change transparency, or I can change from wireframe to hidden lines removed, shaded, whatever I want to do, or completely hide it. Depends which column you click in. Okay, that's what I want this thing to look like when I start my animation. So I'm going to insert a new motion study, and it'll start it in that orientation. Okay. The first thing I want to talk about is the orientation that you're looking at. You can use standard views, or you can use views that you've named. You can even use cameras if you want to for how you're visually seeing the component in its orientation. It's automatically set up to disable key creation, which is nice because if I go to like second 2 and I turn this thing to be straight, if that is not disabled, it'll capture what my view is, and so it'll rotate the view from here to there if I want to, but I don't want to do that. What I want to do is I want to do a 10-second video where I start off in the ISO, and then I'm going to click on this gray bar here. That sets my timeline, and I'll right-click and change the orientation to that side. Whoops, wrong one. There we go, to the side. Okay, what SolidWorks does, or what the animator does, is it'll extrapolate. We're in this position, and now we're rotating it over to there. You can copy and paste these spots, so if I want to go back to the original orientation, I can copy that to the clipboard, say when I want it at 10 seconds, and paste. And so now, the thing's constantly in motion. It starts off in an isometric view, it revolves around, goes into a side view, but it never stops for a second. I'd like it to stop and linger. So I'm going to select this side view again and copy and paste. There we go. So anytime you see one of these bars in your animation tab, or in your motion manager, I should say, what it's letting you know is it's doing a transition. It's going from this key point to this key point. If there's a blank spot like this, that means there is no transition. So what I've done here is I've got it in the isometric, it twirls around to the side, then it stays there for a full second, and then it starts moving again. I'd like to do a couple more things as well. I'd like for this to show actually visually the range of motion. So I'm going to select when I want that to start happening, and then I can simply free drag the component over to here. Nothing's really happened. Again, it's not automatically capturing what I do. I have to tell it, okay, I want you to be at that point at that time. So I just right-clicked at that time and said place the key to capture where I just put it. I'm going to go over here. I'll free drag it to the other side. Enough. Right-click, place key. I want this thing to oscillate, show the range of motion. So again, I can copy and paste, copy, paste, one more, paste, and that should be good enough for them to get the idea. If you want to see what this looks like, if you hit play, it'll start from wherever you were. If you hit this one, it'll start from the beginning. Okay, it's not really doing what I was hoping it would do. That's because SolidWorks actually hasn't recalculated this. So SolidWorks needs to rebuild where the positions are and solve all this stuff. So these two things right here, these two play buttons, whether you're playing from the start or playing from your location, it only plays what SolidWorks has built. And I never have had this thing calculated. So what I need to do is I need to hit the calculation button, and then it's going to actually calculate where things are, at what position, and I think I've got my copy and paste wrong. Okay, so how do I troubleshoot this? You go over here, come to here, This is in the same position. So go into here. I actually want it to be over on this side. I'm going to replace the key. And then I should be able to put this here. There we go. Let's recalculate it again. There we go. Nope. I need to do another copy and paste. Almost there. move it here. All right, so now that I've got it calculated and I've taken a look at where my keys are, this thing should oscillate back and forth where I want it. Notice that I am in using real view graphics. Those are nice because it makes it look shiny and metallic or clear and glassy, that type of stuff. It's a real-time renderer. You can see shadows and stuff as the part spins. So it gives it a nice visual. One thing it doesn't allow you to do, though, is to fade to transparency. If you want something to go from transparent and all of a sudden become visual, you know, sort of go through completely clear and then a little bit opaque and then all the way dark, you can't do that with real view turned on because of the real-time rendering. So real view, when you do find a component here, oops, the angle, that's what I'm after. When I say I want to show this, even though it should go from not showing and then blend, with the real view on, it's right away. So what I can do is I can take it when it was hidden, copy that, and paste it there. So it stays hidden for the first 2 seconds, and then in a half a second it pops up the next one. And I want it to stay visible while the thing is shaking around, and then hide itself again. So you can do visual tricks as far as hiding and showing items. So now when I calculate this, it starts moving, then the words come up. It says, hey, this is how far we can go back and forth, and it swings back into position for me. So you can play around with the view of components. Also, they do give you the ability to edit mates here. You can turn mates off, you can turn mates on. Also, if you have an angle or a distance mate, you can double click on it and say, okay, at 10 seconds, it's 40 inches. At 20 seconds, it's 20 inches. So just by going into the time, you can actually start editing things like distance and angle mates to get yourself some motion too, if you want to control it a little bit more than just free dragging it. All right, so I've got a quick 10-second video. I'd like to do that exploded view, so I'll use the wizard. I've got 10 seconds. Let's start the wizard. Oops, that's the wrong button. That's the save. We'll do that in a second. Start the wizard. The animation wizard, what it does, it has a few different things. If you've got some motion analysis already put in there, and we're going to set these up later, you can actually bring those into your timeline. You can have it just rotate around an X, Y, or Z axis if you want to give guys a fly through, or a fly around, I should say. Or if you've got an explode view or collapse, these will be available. So I can explode this. It starts wherever the thing left off. So it starts at 10 seconds and lasts for 4 seconds. And what it's going to do is it's just going to change the position of where these components are. Turn my display pane because it didn't look quite right. So notice this is coming out, and then the retaining ring starts to slide around. You can change when things happen. I can click and drag on these as well as copy and paste. So if I want the ring to start moving before the pin, I can change when things happen just by clicking and dragging on these keys. I'll click to here and let's play this again. Okay, it shakes back and forth. Then we start exploding and the ring comes out before the pin. I can use the wizard again if I want to collapse. Again, now it's actually starting wherever I leave that gray bar. I want this to start at 14 seconds. There we go. Now I've got it exploded and collapsed. Calculate everything again, and then we can just play it from the start. Okay, Some of the things in the animator, I've talked about the fact that it needs to rebuild whenever you're making changes. That can lead to it being really top heavy. If I usually will just make really short videos and clip them together. It's a good idea to use an orientation like some sort of home location so that you can have one video stop and then visually it starts up on the next video at the same location because you're using the same camera or the same view. Again, the problem has to do with the rebuild. If you have a minute and a half of video and then you're trying to edit around 1 minute or 1 minute 15, it has to continually rebuild the minute before it to figure out where the components were. So it's a really top-heavy system. So it's a good idea to make short vignettes and then stitch them together using Camtasia or some sort of Windows video editor. How do you get them to be made? Well, you just hit the Save Animation. Again, I have a frames per second that I want to bump up a little bit here. Also, when you're doing it from the toolbar, you have the choice of whether you want to do the entire thing, just edit a single frame, or whether you want me to make a video of the entire process from 0 to 18 seconds. That's what I'm after here. You also have different file types that you can do. MP4 is one that's pretty good. AVI, it's an older file set. It's kind of big. MP4 seems to be smaller, and also you can upload it to YouTube really easily, things like that. So I just said, okay, let's save this. What it's going to do is before it saves the video, it says, okay, one last time, I'm going to recalculate this all. It's a good idea to watch this recalculation. If something goes awry, you can stop it and cancel out of the save. But SolidWorks always wants to rebuild everything before it creates that final AVI. Okay, so it's finished with its calculations. Probably should have had that view a little higher, but that's okay. Ooh, and I should have fixed that ring. So I can go back and change these things in the Motion Manager after the video is saved, but at this point, it should have saved the video. If I go into desktop, now I've got a video that I can send to somebody when they say, what's the range of motion? Say, just watch this, or how's it go together? Same thing. So these are the great types of things for the SolidWorks animator to do, just sort of a proof of concept, range of motion, that type of thing. A short vignette. If you're going to make anything that's longer than a minute, again, stitch together small videos. If that's not what you're after, you may want to go for something a little higher and like Maya to do your animations. Okay. Let me get into some more examples here. Let's close out of this. All right. Close down everything I got running here and just open an assembly because I want to bring up an important fact about the motion that you put into SolidWorks. So you recognize this little thing. It needs to have that pendulum action, that 66 degrees that I had set up in order for it to do this boxer motion. You'll see that both of my assemblies here, they don't look like the usual assembly icon. My usual assembly icon, which is at the top of the tree, looks like a part icon with a little blue block sitting on its shoulder. But these look like a part icon with a little blue block floating over its shoulder. That means that that subassembly is set to flexible. I can click on it, and you'll see that it changes back. It also changed the orientation. The orientation that it uses, if it's not set to flexible, is whatever orientation it was last saved in at the subassembly level. But you see that when these things are set not flexible, I can't move anything. In fact, if I only set one of them to flexible, so I just a single click, come on. I do not want to rename it. Single click, there we go. Just one of them is not good enough because both of them have to move. So anytime you have motion inside a subassembly and you want to have that motion carry over into the level that it's next above, you have to set it to flexible. And what it does inside the assembly, it actually keeps track of what location the assembly is in. It doesn't have any effect on your subassembly file in itself as far as what orientation things are in. If I open this again, it's going to be straight up and down, just like the last time somebody saved it. All right, another thing with the Motion Manager, I should let you know one thing that I was driving me crazy is this click here. Of course, it's working every time because you guys are watching me, but sometimes when I'm by myself, I click there, I don't see anything. It's because I have a touch screen laptop. If I actually touch that button with my thumb, I have a better chance of seeing what I've got as far as motion studies and models. If you have more than one motion study, it'll list them all here and it'll take you to the time chart for that motion study. In the last motion study that I did, I selected a part and I just free dragged it to give it the motion. But sometimes you want to have a little bit more control over that, and also it's kind of a pain for me to like rotate this at a perfect speed and capture that. So what I can do is I can add a motor. When I select on a piece that's got a rotational aspect to it, it'll take that and it'll spin it about the axis of the cylinder that I just picked. You can change which direction it's going to go. You can also change the speed. I'm going to use a constant speed, but you can do oscillating, you can have it ramp up. There's all different types of ways that you can have a motor applied to your system.
Hey Lars, is the motor always grounded, or can you have a motor operating on a platform that's spinning?
The motor, it's theoretical.
Or would you
You
put?
don't actually have to place anything on it. All you have to do is just say, okay, this axis is going to spin. And it'll spin whether that axis is moving around. If it's on some sort of table or thing that's shuttling around, it doesn't care. It's orienting it to the axis that you selected. Does that answer your question?
It may, but it's
I've
fine
got
for the
another
moment.
example I'm going to open up where it's got a bunch of different motors on a system, and they act at different times, because you can also have a motor turn on and turn off at a certain time as well. If I go to a certain time, I can turn that off or turn that on.
Well, what I mean is, say you got a car and you rev it, and the torque reaction makes the car, rock on its suspension. So there, the motor isn't grounded; it's on another platform. So that's what I'm asking. Can you establish the motor's frame reaction against some other assembly or component?
Okay, I hear what you're saying. No, not really. I mean, what the kinematic thing is going to do is it's going to spin around that axis for you. It's going to give you angular velocities and motion and things like that as to how your assembly is set up. But if you're looking for like vibration caused by the motor going or things like that, that's a whole. There is a frequency analysis that you can do. But the kinematics really isn't going to do that for you.
Okay, all right. Don't let me derail you anymore. It's fine.
Oh, not a problem. I already have seen this presentation since I did it without sound yesterday. So here we go. I've put on that motion just 100 RPM. It starts right away. You see, I don't have to crank it myself. So you can put on motors, and again, this depends on the type of mates that you put in. If I hadn't mated the assembly so that when I crank on the subassembly, it turns the pistons, none of that would have worked. So you do have to get your ducks in a row as far as what type of freedom of motion you have, and that will determine how the assembly reacts when you start putting on things like forces and motors, which you can do in either of these. Oh, one more thing I did want to talk about when we're talking about motors. You want to be careful with this frames per second, because you get that whole wagon wheel type of thing in the old films where the wagon wheels go backwards, or a strobe effect. If you hit it perfectly where the RPM is always top dead center, every frame is going to be top dead center and the thing's not going to move at all. So you want to be aware that of your frames per second, that you kind of don't want them divisible by the RPM that you're putting in there. And that'll help out with that type of thing. But I've had that where I do an animation and I play it and the thing kind of has a strobe effect or it doesn't move at all. Play around with your frames per second, you might have a better chance at it. Okay, so it's making a video for me right now. Should give me an audio.
Hey, Lars.
Yes, sir.
This is John here. Can you get any really simple analysis out of this? Like, can you get the speed of the piston head or the position of the piston head out of this?
That is a beautiful question because I was just about to show that. The answer is yes, you can. What you want to be conscious of is this over here. So far, I've only been using the animator. The animator is really low budget. It comes with the basic package, and it only does what I've been showing you here. Simple motors, free drags, things like that. Explode, collapse. You can get away without having to check out that professional license. But if you want to do anything of any value, you're going to have to bump that up. Basic motion, motion analysis are the two that allow you to get better results. Especially when you're doing things that have mechanical mates, like gear mates or things like that, the animator is terrible. At some points, it'll start spinning and then the gear mate will go past 360 or 0. It'll get confused and it'll start going the other way. So animator has given me some really horrible animations. Basic animator is a little better, but since we already are using a network license where we have access to it, and since this motion analysis is on the professional level, just run with that, because the motion analysis is going to calculate those things like mechanical mates and gravity and springs for you better. And also, to get to John's question, it allows me to start running reports. So if I click on this and say I'd like to find some results here, there's different types of things that I can find. And so your question was, can I find out how fast it's going or the motion? Here they all are. So I can find out a momentum. It even has some other quantities that you can look up as far as some kinematic results that you're after. I'm just going to do a velocity. So I want to find out the linear velocity as it is to this x component. So I had to take a look down at my triad and make sure that I'm going the correct way. And what it does is it'll resolve that and it gives me a result here. Show it. Where is it? Oh, there it is. Okay, I just need to recalculate it for it to come across. So here is how fast that piston head is moving. You see that it gets, when it gets closer to the top or the bottom, the speed picks up, which you would expect, you know, as the yoke goes up over the hurdle and then starts pushing it really fast. So you can get information like how far does this move, how fast does this go. In another example, I'm even going to show you a trace path. Hopefully that answers your question.
Yep, that was fine.
Okay.
Thank you.
Perfect. All right, in my whole automotive phase here, I'm going to show you one more example here with a cam. And what I want to do with this one is I'm going to do a motion study, but this time instead of just animation, I want to see how this thing works. So
that looks like a wear issue.
yeah, I do have to say I grabbed this one from SolidWorks.com. Not my model. I would have probably given it a rounded head at least. Anyhow, let's put a motor on here. And I'm going to change the speed. In the last one, I did a constant speed on this thing. But this time, I'm going to do it by something called segments. And what segments allows you to do is there's all kinds of different ways I can do this. I can do it by data points. I can write my expression. Or I can make, okay, for 0 to 10 seconds, it does this. From 0 to 5 seconds, it does that. Using the segments type of thing. So I can click and say, from here to here, I want this going 360 degrees.
So you're entering displacement and it's calculating the velocity and acceleration that corresponds to that?
Yes.
You could put in acceleration or other factors if you wanted?
Yeah, there's different types of things that you can put in here. So I can do it by,
all right.
Do I want displacement, velocity, acceleration? So there's different ways that I can apply the motor rather than just saying, hey, it's this RPM to get better results. The more closer to reality you can get this type of thing running, the better it'll be. So, okay, I've put a motor on this thing. I've got it under motion analysis. So let's calculate it. All right, didn't take long. Oh, it's not moving at all. Let me check out that motor again. I think I might have just... Okay, hold on. Let me try that motor again. I think I just picked the wrong face that I applied it to. So if you do want to get rid of something in there, I'll just delete this. Let me try it one more time. Motor. This is info I had to pick that face. Okay. Let's try this again. So that's without it calculated. There it is. It's calculated. So nothing's happening. This is just like when I was in the very beginning of my example where I was moving the piston back and forth and it was running right through it. I had to tell it, hey, I want to do a collision detection. I want you to check to see if these things are actually running into each other. You have to do the same sort of thing inside of here. So here's the motors. Here's putting in things like springs and dampeners, forces. Another thing we have to talk about is contact. So I'm going to say these two pieces come into contact with each other. All right, let's recalculate it. And off it goes. So what's happened is I've just invented a pin launcher because nothing's holding that in place. When SolidWorks is running an animation, it's kind of like you're in the void of space. If you knock something, it just keeps going. It's off to Alpha Centauri with that thing. If I zoom back a little, this is how high up it went in 5 seconds because there's no gravity. So next thing they've got is a little tribute to Isaac Newton with the apple here. I just say, okay, there's gravity on the system. All right, here's a pet peeve of mine. SolidWorks tells me that X and Y is the front plane, yet every time I come into here, it has the Z plane as my axis of gravity. I want it in the Y, and it automatically has it set to gravity on Earth. If you want to do it for Mars or the Moon, you can change that acceleration. All right, let's try that again. Recalculate. Hey, that looks a whole lot better. So this thing needs to have gravity on there. What if we're flying upside down? What if it's some machine that is on a space station or something like that, and we don't have gravity? You can also put on springs. So if I say, let's do a spring, I pick either the face or the edge where the springs are attached. You can put in the information, you know, how whether it's a straight one or a round one, like a wind spring type of thing for a watch. All of the information for, you know, what the tension is on the spring, how strong it is. So I say OK, and I'll recalculate it again. It even shows you, you know, visually the spring going up and down. You can play around with how many coils it has and things like that, but that's really just a visual. It doesn't do anything for you. The real information is when you put in that spring strength. Okay. I did want to show you one more thing, and that is complex. So a little earlier, Jim was asking me about putting motors on things, and I told him it's not going to solve the frequency issue that you have if you have a motor sitting on a system that's not held down. It is going to shake, but this is not really built for that. You're going to have to incorporate some other stuff as far as what you get from there. But you can, if I go into here and play this animation, what they've got going here is they've got motors happening at different times. So one motor flips the latch, another motor locks it, and then there we go. We've proven out whether this latch thing actually will grab where we thought it would. Of course, we've got these motors. We've got a ton of contacts between everything. So I guess that's to answer your question, that if you put a motor on something, that certainly can move around, and the motor is always just going to be stuck to the axis. Another type of report that people ask me about, besides velocities and things like that, is something called a trace path. And what a trace path allows you to do is you can pick a vertex or a point somewhere on your system, and you'll see what it does for me is it draws where that point goes through your animation. So when I play the animation, I can see that's where that point ends up. It's kind of nice. It puts a visual curve on there as a result. It's not geometry yet, though. If you do want to create it as geometry, you can tell it to create a curve from the path, either inside of this assembly, or you can have it open up a new part and do a curve. I'm just going to do one inside of this part because I know that this one has some problems. It's taking a second. Again, 2019, just to let you know, if you ever see that hourglass down here in your taskband, that means it's working on something. It's a little nicer in 2018 where I had no idea if something was happening. But there we go. I've got a curve here. It's got an error in it. The reason it's got an error in it is it gets a little crazy here with that. And maybe this is, the reverberation or whatever from that thing actually clamping down, but that's the reason that this thing has an error. If I go to edit it, what it'll show me is it'll show me the X, Y, and Z. So if I did want to make geometry out of this, I'd either sort of trace over it, depending on how important it was. If it was really important, I can go through here and start getting rid of like redundant points and things like that, try and clean up this whole scratch mess that I got in here. Okay, does anybody have any questions for me?
Or I play with it, I'm sure I will, but it sounds pretty good right now, Lars. Thank you.
Yeah, again, this was just a primer. If you do want to get your hands on it, SolidWorks is really good about online tutorials. If I go to SolidWorks tutorials, there's 2 videos on here Show me all. You've got an animation video right here where they have you do a mechanical sort of proof of concept thing. And they've also got a motion study where you do a cam with a spring, sort of like I was doing, only this one's a whole lot better. It looks a lot like a real cam. One of the nice things about this is as you go through it, if you're not sure where a choice is or something like that, you can click these items and it'll actually show you on your screen, hey, click here, and this is what'll, do what you want to have it do. So the tutorials are a great place to get some more information. Also, if you go to our homepage, go/x-mechanical. I always like to plug this. Here's our team. There's a training. We're going to have more training next month. We've got a dojo coming up if you guys want to sign up for that. But we've also got a ton of videos posted up here. It's probably like a couple of days if you're tired of being stuck at home and would like to just binge watch SolidWorks. You can do it all this weekend. But here's animation in motion. That one's about an hour and a half. If you go to my YouTube page, there's also one that Hawk Ridge Systems did for us. Oh no, it's here as well. Here's the one they did for us in 17. So there's one that I did that's kind of a longer version of what I just showed you. And then there's this one that's another person showing other aspects of it. So there's some resources for you. Thanks everybody for showing up. We are going to be doing more of these lesson learns as we're all stuck inside. So I'll be sending out emails.
I have a question, Lars.
Sure, what's up?
You remember the master model question that I had? So, yes. I love to use master models or master model sketches for assemblies now, but a price you pay for that is you don't have mates.
Yeah, and I talked about that when I first started out in this.
Oh, sorry, I missed the first 5 minutes.
It's okay. I had the spiel for you, but what I talked about was when I brought this pin in, I can do it again here pretty easily. It comes in just like a master model because I actually modeled the thing in the correct position that it's in the assembly. And that is a great design tool because I know the thing is going to pop in where it's supposed to. And this is the same thing that you get when you do a master model. The thing just appears in the space that it's supposed to be and it's fixed in space. You don't need any mates, which is great if the part doesn't move. If the part does move, you do need to, right click on that, tell it to float, and then start putting in the mates that allow it to have the motion that you're trying to find out. Because you're right, if you just drop it in from a master model, bang, it's net XYZ location, and it's never going to move until you float it.
So what happens if I go back to the master model and make the change in the top level sketch, which is the advantage of it, of course? Does the sketch trickle down into the floated part properly? I guess we could try that easily enough. I can try that on some of my stuff.
Yeah, because it should, because the part's going to rebuild according to the sketch. But then once we get to the assembly level, if you no longer have it fixed in location, it should rebuild wherever you've mated it to. But it does get dicey there because, if it's in context or something like that, and it keeps resolving to a certain edge, that could be problematic.
Yeah. It's a tricky one.
It is.
It's the good and the bad of master models. They're fantastic for really keeping things organized, but I think
right. And I typically will do. I love doing the master model for the enclosure, for all the plates inside, for all the stuff that's not moving. It's great because you're in there. But if you have something that's going to move, just don't put it in the master model. Just model it outside and then mate it into the assembly, or have some dummy in there, a dummy part in the master model, just to sort of represent it, because otherwise you're going to get a part that keeps wanting to resolve to its location.
It's also a problem in simulations where you're doing a design study, and so you're asking some parameter to change, maybe a dimension to keep changing. You're asking the master model to keep changing. Other question I had related to the motion study is, I put it in the chat. Can you put simulation results at the end of a motion study? Or so if in simulation I get a temperature map. So I wouldn't mind having that, let's say, on the parts as they're...
I know that you can put through like forces and things like that. You know, that I was showing you that you can find out forces and angular momentum and things like that. I know that there's a way that you can port that information into a study. You know, we got this angular velocity going here, and you can put it into like a stress and strain.
Okay.
For a force or something like that.
And you can probably drop in an AVI from, say, FlowWorks at the end of the AVI that the motion study did, or something like that. If you have vector flow, you know,
right.
showing
It would be really hard to merge the two, you know, to superimpose them, but to have two separate videos would be easy enough.
Yeah. Okay. All right. Hey, as always, thanks. You're an excellent instructor, Lars.
Oh.
George and I were chatting about it while you were talking. You're just really good at this. Thank you.
Cool. I'm happy I can be here for you guys, especially since, you know, it's uncertain times. Just have a happy Friday, right?